All right, we have another word problem here for number 5. It says the size of a TV screen is given by the length of its diagonal. So this is the length of its diagonal, which is 27 inches. The screen aspect ratio is the ratio of its width to its height. The screen aspect ratio of a standard TV screen is 4 to 3. So that would mean the width would be 4 and the height would be 3. That would be the ratio, 4 to 3. What are the width and height of a 27-inch TV screen? All right, well, basically we can use similar triangles, but we will need to find the hypotenuse right here of this 4 by 3 rectangle. So to find the hypotenuse, we'll call it x, and then we can use the Pythagorean Theorem, which says 4 squared plus 3 squared equals x squared. 4 squared is 16, and 3 squared is 9. 16 plus 9 is 25. X squared is 25, and x would be the square root of 25, which is 5. So that's how we got 5 to be the hypotenuse of this 4 by 3 rectangle. Now we can use similar triangles. So we can set up a ratio or a proportion that says 27 over x equals width, or w, over 4. Again, 27 over x equals width over 4, and that's what we have over here on the right. So we get 27 over x, which is 5, right? So 27 over 5 equals w over 4. Cross multiply, 5 times w equals 27 times 4, which is 108. We'll divide both sides by 5, and 5 goes into 108, giving you 21.6 for w, which is the width of the television screen. And then to find the height of the television screen, we can use a proportion again. So we can say 27 over 5 equals height over 3. So we have this written here. This is 27 over 5 equals height h over 3. Cross multiply, 5 times h equals 27 times 3, which is 81. And then we divide both sides by 5. So that's 81 divided by 5 will give you 16.2, and that is the height of the television screen. So the width is 21.6, and the height is 16.2. All right, in number 6, the directions here says let B equal 65.4834 degrees. Let little c, which is this side here, equal 3954.5 meters. And then it says solve the right triangle. So to solve the right triangle means to find all of the missing angles and all of the missing sides. So I decided to find the missing side A first. So I labeled this angle B as 65.4832, as it was stated here. So this is angle B. And I recognize that A, side A, is the adjacent side of this angle, and that this 3954.5 is the hypotenuse. So I know, using SOHCAHTOA, I know that cosine is adjacent A over hypotenuse C. So I can say cosine of the angle 65.4834 degrees equals A over hypotenuse 3154.5. Then to solve for A, I would simply multiply both sides by 3954.5. So A would be 3954.5 times the cosine of 65.4834. We enter this in our calculator, and we get A is equal to 1640.9. We can do something similar to find side B. Side B is opposite of the angle 65, and side C is the hypotenuse. So we can use the sine ratio. Sine is opposite over hypotenuse. So we can say sine of 65.4834 degrees equals opposite, which is B, over hypotenuse, which is 3954.5. Multiplying by 3954.5 on both sides, we get B is equal to 3954.5 times the sine of 65.4834, which gives us 3597.7. So that is B. Finally, this angle here is missing. Angle A is the only angle that's missing. And we know that these two angles, angle A and angle B, have to add up to 90 because we have this right triangle here, or this right angle is 90. So we can say, and we know 90 plus these other two 90s makes 180. So basically, we know that A and B add up to 90. So we can say A must be 90 minus angle B. So 90 minus 65.4843 equals 24.5166. And these are the three missing pieces for number 6. Okay, for number 7, we have this right triangle, and we're trying to find x. Well, we have this side is x, this side is x, and the hypotenuse is 5. Using the Pythagorean Theorem, x squared plus x squared equals 5 squared. X squared plus x squared is 2x squared, and 5 squared is 25. Divide both sides by 2, and x squared is 25 divided by 2. Take the square root of both sides. So x would be the square root of 25 divided by the square root of 2, which is 5 divided by the square root of 2. And then we can't leave the square root in the denominator, so we'll multiply the top and bottom by square root of 2, and that gives us this final answer, which is 5 square root of 2 over 2. Okay, we have a word problem for number 8. So we have an architect designs the front view of a house with a gable roof that has a 45-45-90 triangle shape. And so here's the 45-45-90, 45 on the right angle, 45 the left angle, and then at the top is the 90 degrees. The overhangs are 0.5 meters each from the exterior walls. So that's 0.5 here and 0.5 here. And the width of the house is 16 meters. So all the way from here to there is 16. What should the side length L of the triangles be? Round your answer to the nearest tenth, I believe. So, I just redrew this triangle right here. So we have this length is L, this length is L, and this is 17. Now where did I get 17 from? Well, you got 16 from this corner here to that corner there. But then you've got an extra 0.5 meters hanging to the right and an extra 0.5 meters hanging on the left. So those two 0.5s give you an extra meter, which is added to the 16. So that's how we get 17 right here. All right, using the Pythagorean Theorem, we have L and 17. So L squared plus L squared equals 17 squared. L squared plus L squared is 2L squared. 17 squared is 289. Divide by 2. So L squared is the fraction, 289 over 2. Well, I take the square root of both sides. So L is the square root of 289 over 2. And that square root should be over the entire fraction. Okay? That square root's over the entire fraction. And then, so what that is that's just the square root of 289, which is 17. And then the square root of 2 is by itself on the bottom. And then we can't leave the square root on the bottom, so we'll multiply the top and bottom by square root of 2. And that gives us our final answer here, which is 17 square root of 2 over 2.